Hello guys, this is Lenny.
This is Marga. I'm Siti.
I'm Jalil. I'm Jubair.
We are going to show you the steps on how to solve unbalanced transportation problems using MODI or modified distribution. By the way, what is modified distribution? It provides more efficient procedure in the computation of the improvement indices of unused cells in a particular solution. We have here a sample unbalanced transportation problem. A trucking company moves materials between 3 plants and 2 projects. Project A needs 2,300 loads, while Project B requires 1,400. Plant M can supply 1,000 truckloads. Plant N requires or supplies 1,200 truckloads, and Plant P supplies 1,300. Here are the costs of delivery from each plant to each project. From Plant M to Project A, 1,600. From Plant M to Project B is 4,300. From Plant N to Project A is 2,000. From Plant N to Project B is 2,160. From Plant P to Project A is 2,040. And from Plant P to Project B is 1,360. Step 1. We are going to set up the transportation tableau. Provide an additional row for the computed R values and an additional column for the computed K. Now, put all the data inside the table. Since the demand is greater than supply, we are going to add dummy on the row. If the supply is greater than demand, we are going to add a dummy on the column side. You see that we added the plant dummy on the row side so that the supply will be equal to the number of demand. Put on every right side corner of every box the cost of every transportation.
Step 2. Develop an initial solution. Use northwest corner rule. Starting at the upper left-hand corner of the initial table, the supply available at any row must first be exhausted before moving down to the next row, and the demand of any column must first be satisfied before moving to the next column to the right. The sum of each row or column must be equal to its rim requirement on the capacity constraints of sources and demand constraints at destinations in transportation problems. To get the transportation cost, we must multiply the use of cells with cost on the upper right corner of the cell. 1,000 times 1,600 is equal to 1,600,000. 1,200 times 2,000 is equal to 3,400,000. 100 times 2,040 is equal to 204,000. 1,200 times 1,360 is equal to 1,632,000. For a total transportation cost of 5,836,000 pesos. Then we are going to proceed step 3.
To test for the solution for improvement, let us compute for the values of R and K for each solution using the formula. R plus K is equal to C, where R is equal to computed value of row, K is computed for value of column, and C for the value of cost of stone cell. These values are used to evaluate the improvement indices of a new cell of a particular solution. Each solution may have different values of R and K, which could be positive or negative or 0, and R is always equal to 0. Now let us compute for the values. R sub 1 plus K sub 1 is equal to C sub 1 and 1. 0 plus K is equal to 1,600, so K sub 1 is equal to 1,600. Next, R sub 2 plus K sub 1 is equal to C sub 2 and 1. And R sub 2 plus 1,600 is equal to 2,000. R sub 2 is equal to 2,000 minus 1,600, and R sub 3 plus K sub 1 is equal to C sub 3 and 1. And R sub 3 plus 1,600 is equal to 2,040. R sub 3 is equal to 2,040 minus 1,600 is equal to 440. R sub 3 plus K sub 2 is equal to C sub 3 and 2. So So 440 plus k sub 2 is equal to 1,360. And k sub 2 is equal to 1,360 minus 440, so k sub 2 is equal to 920. R sub 4 plus k sub 2 is equal to C sub 4, and R sub 4 plus 920 is equal to 0. And R sub 4 is equal to negative 920.
Then, evaluate the improvement index of each unused cell using the formula C minus R minus K is equal to improvement index of a particular solution. MB is equal to 4,300 minus 0 minus 920 is equal to 3,380. NB is equal to 2,160 minus 400 minus 920 is equal to 840. BA is equal to 0 plus 920 minus 1,600 is equal to negative 680. Now, let us check for the degeneracy using formula. Number of used cell is equal to rim requirement minus. The most negative improvement index is negative 680. Now, let's proceed to the next step.
Step 4. Develop an improved solution. Trace a closed path for the unused cell having the largest negative improved index. To trace a closed path, move vertically and horizontally but never diagonally from the unused cell to the used cell or stone stack to the original unused cell. In tracing closed paths, you may skip over unused cell or over stone cells or may cross over itself, but its concerns may occur until at the stone cell and at unused cell being evaluated. Sign plus and minus sign at alternate corners of the closed path, starting with plus sign at the unused cell as shown in the table. Smallest stone in a negative position on the closed path. Add it to all cells with the plus sign and subtract from those with minus sign. Since 100 is the smallest number, then BA 0 plus 100 is equal to 100. PA 100 minus 100 is equal to 0. PV 1200 plus 100 is equal to 1300. DB is equal to 200 minus 100 is equal to 100. Then copy the cells that were not improved. Enter the data that were improved as well.
Compute the transportation cost. 1,600 times 1,000 equals to 1,600,000. 2,000 times 1,200 is equal to 2,400,000. 1,360 times 1,300 is equal to 1,768,000. 0 times 100 is equal to 0. 0 times 100 equals to.
The transportation cost is 5,768,000 pesos.
Compute the values of R and K. R sub 1 plus K sub 1 is equals to C sub 1, 1. 0 plus K is equals to 1,600. K sub 1 is equals to 1,600. R sub 2 plus K sub 1 is equal to C sub 2, 1. R2 plus 1,600 is equal to 2,000. R sub 2 is equals to 2,000 minus 1,600. 1,000 sub 2 is equals to 2,000 minus 1,600. R sub 2 is equals to 400. R sub 4 plus 1,600 is equal to 0. R sub 4 is equal to negative 1,600. R sub 4 plus K sub 2 is equal to C sub 4, 2. Negative 1,600 plus K sub 2 is equal to 0. K sub 2 is equal to 1,600. R sub 3 plus K sub 2 is equal to C sub 3, 2. R sub 3 plus 1,600 is equal to 1,360. R sub 3 is equal to 1,360 minus 1,600. R sub 3 is equal to negative 240.
Test for improvement. MB 4,300 minus 0 minus 160 is equal to 2,700. And B, 2,160 minus 400 minus 1,600 is equal to 160. DA, 2,040 plus 240 minus 1,600 is equal to 680. Since there are no negatives, it is the optimum schedule. Then, check for the degeneracy. 5 is equal to 6 minus 1. 5 is equal to 5. Now, they are equal.
Then the decision is table 2 is the optimum schedule with the transportation cost of 5,768,000 pesos.
If we encounter a problem when there are still negative answers in the test for improvement, it is not an optimal solution yet. So you must repeat steps 3 and 4